simple and it's usually hard to beat. Okay, what is bag of words? Basically, you have your entire. Remember, everything about like in NLP, everything's about vocabulary, and you gotta have vocabulary, especially if it's a supervised task. How you create bag of words is you index your entire vocabulary. Let's say you have I don't know 5,000 words. So you count all the words, you list them, then you use the set operation in. If you want to do it manually, otherwise you can use NLP as we have discussed, and you get a vocabulary. A vocabulary is nothing but a hashed table of indices and words, right? Or words and indices. Actually, you need both ways because sometimes you translate to indices, sometimes you translate back from indices to words. Regardless, you have that vocabulary. Now, what bag of words does is creates, instead of that mechanism that we use in deep learning, creates a vector of your vocabulary size. That's a big vector, right? So you want vocabulary size to be smaller. Prefer that. Anyhow, you create that entire vector, and for each document, for each piece of text, you just input one, add an index representing a word that occurs in the document. If the word doesn't occur in the document, it's represented by a 0. That's bag of words representation. What we call it bag of words because it has no information about the sequence. And the order of the words is just arbitrary. Like the order is just signify the item, the vocabulary item, nothing else. Like the third component in that vector always refers to the word cat. Always refers to the word cat, nothing else, right? So if that's 1, in a second I'll get to it. If it's 1, that means that the word cat occurred. It also doesn't get the frequency by default. It just tells you the word occurred. And you more often than not in text classification, that's more than enough, especially if it's sparse. I say that in the notebook as well. So that's your bag of words. Now that I already got your attention, I'll also tell you about the frequency bag of words. Frequency bag of words is the same thing. Aside from having 1 and zeros only, you have 0 frequency, and that's it. So you don't have 1 anymore. I mean, you have 1 if it only happened once, right? So that's your frequency bag of words. And then you have TF-IDF, which is, okay, you're just giving me these frequencies, but you're biasing me towards larger text. Because if you have larger text, then you will have more occurrence of certain words, right? Then does that mean these two texts are different? No, they're not. Like two texts could have the exact relative number of word occurrence in them. So 20% of time in this text was the word, I don't know, da, for example. Exactly the same percentage was the word da in this other corpus. This corpus is 20 million words, this corpus is 200 words with the same exact distribution. You don't want to discount that. You want to see the distribution rather than the relative frequency rather than just raw frequency. That's a side effect of the size of the corpus. To take care of that, you use TF-IDF. You create your frequencies by TF, term frequency, and you just normalize it by document frequency. So divided by the document size, right? That's it. Exactly. Okay. So in the notebook you have use IDF equals false. It's because we just want to get the frequency bag of words for that cell. So you have two cells. One says here use IDF is false. That gets you easily the frequency vector. The cell right below it gets you the normalized IDF vector. Why do we need both? You don't really. We know TF-IDF works better. I mean, you were supposed to find it out by this notebook, but I'm telling you. So at the end of the notebook, you run both. You have a parameter selection. You have a parameter tuning where you run the entire pipeline and search for the best parameter. You see that we will select TF-IDF as opposed to not, as opposed to the TF. Yeah. So TF-IDF and TF are nearly that same vector, exactly the same size. It's just instead of 0 and 1, they have either frequency or a normalized frequency in them. That's all they are. All right. Thank you. Thanks for the attention.
Okay. Am I hearing an echo? Okay. So we're getting started on the second part. There was a very good question online. I added a cell in the notebook to address that question, and I'm going to explain a little bit the differences right now, and then we can move on to the final project. So the question was why, if TF is term frequency and count vectorizer also gives us the frequency, then what's the difference? So I created a cell at the end of the notebook. If you can refresh your pages, you should see that. It's called, well, I created a section. It's called count vectorizers versus term frequency versus TF-IDF. The last bit I just added. So you refresh, you should see it. And basically, I'm printing out the type of each object, as well as visualizing the first item in each object, or in each. I think it's some sort of a similar to a tuple, but it's a class. So the first item in your data set, right? Think of it as some sort of a list. And you can see that count vectorizers literally just gives you the counts. This is the first one is count vectorizers, right? Vectorizer, right? So count vect, right? It just gives you literally the count of each word, right? And then your TF gives you a normalized count frequency. So it is normalized based on the number of sort of words in a document. Number of words. Okay. Now what's an IDF? So TF-IDF takes that because you want to normalize it across all the documents. You want to have an understanding. TF-IDF doesn't give you only a normalized representation of a word in a document, as I kind of led you to believe before. It gives you a measure of specificity. How specific now this word is to this document. That's why it divides by the inverse. It divides by the document frequency. So how frequent is this document? Frequency. How frequent? Okay, I'm debating myself. So what's the? Give me a second. I think it's just the frequency of a document. Okay, let's look it up together. Yeah, I think it's just, you can verify it, but I think it's just the frequency of a document or frequency of a term across the documents. Ellie, could you look it up? I don't remember it for some reason. Yeah, if somebody remembers, tell me. Okay, anyhow. Across all the documents, ratio of the word across all the documents. I'll look it up and tell you what exactly it is. But what it does is it gives you a notion of specificity. How specific it is this frequency that this word is to this document. That's what it does. So that's the difference. So it changes the normalized frequency into a specificity score. That's what the TF-IDF is. For some reason it escapes me. But that's, yep.
So it makes, so even this particular word will be used many times in this particular document. So say it will be 100 times mentioned in only one document. So we will get the less score than if we...
Exactly that. But that line of reasoning, it can be the frequency of the word across all the documents. I think I'm pretty sure that's what it is. It's very rational, so I always I don't memorize this concept. I always reason through them. Basically, what you want to get is okay. This word is very frequent, and even the normalized frequency per that document is going to be high. But then how it compares with the rest, like what is this type of word very specific to this type? Because remember, we want to represent the document, right? So if we have the frequency of the word across all the documents, and we normalize by that, then we see, let's say it's highly frequent here, but it's also highly frequent in all the documents. I'll get to you in a second. Then they cancel each other out. So it really doesn't really represent this document as distinctive from other documents. But if it's super high frequency, like a normalized would be, I don't know, 20%, and then in other documents it's like 0.00001. Then you gotta, if you divide by that number, you're gonna increase the importance of that component in the vector, right?
Yeah, I went through the definition, and it's basically the average frequency across a collection of documents or corpus, which means like it shows the importance of the word or frequency in a bigger corpus, not just
Gotcha.
one specific.
Gotcha. So one way. Okay. So what Ali said, for if you didn't hear him online, he says it's an average the frequency of that word across all the documents, right? Regardless, it's a measure of frequency across all the documents. Well, if it's average, it's a kind of centered measure, right? So you get a sense of how frequent this word is across all the documents, and then you divide it by that. It will ramp up the importance of that component of that word in your document. If that's very specific to your document, if it's very general, it's going to bring the importance down. So your classifier, has an easier job detecting distinct characteristics of each document. Is everybody clear between IDF, TF-IDF, TF, and count vectorizer? There is a cell. You can take a look at it as well. All right, beautiful. Yep.
Embedding exercise that you're having has to, which is like the most basic form was just the average, like you take the total count, for example, of the words, and then you divide it by like the total number of documents or something like that.
So word embedding is, like when you say word embedding, people sometimes use these things interchangeably, and that's perfectly fine. But right now, for the purpose of this exercise, we mean word embeddings generated by word embedding algorithms such as word2vec or GLOV, or even deep algorithms such as transformer networks. Okay. Yeah, but you can call the output of the TF-IDF an embedding. You can call it an embedding. It's technically, I prefer not to say that because it came from deep learning embedding, and it's how you embed a word into a multidimensional space. But nothing wrong with that. The difference over there is that you get word representations. Your TF-IDF is a document embedding, right? Now there is this document version of word2vec. It's called, I think, doc2vec. I don't exactly remember how they created. I can imagine a few ways right now, but you can use that also. But I wanted you to really use word2vec and go through the practice of making a document representation out of words. Okay. If
One question.
yeah. Mm-hmm. I can.
Yes, we can now.
You could go ahead and paraphrase me.
Yeah, okay. So Ramya was just saying that she removed the TF-IDF from the pipeline.
Yep.
And instead she used an FDF and was able to get even better results. And she was wondering if there's any insight as to how that could be.
Okay, great. Do you want to mute the speaker? So great question. I repeat the question. So the question is, I tried a bare frequency or term frequency, normalized frequency, either of them, doesn't matter. And I used SVM with it, and it worked better. Okay, two answers. One is that if you want to say something is better, you have to have an entire grid search. If you do have an entire grid search, and that means that means. So you want to make sure it's not, you're looking, when you say it's better, you're saying that it's better than every other combination, right? Or every other parameter. It could be better for that specific algorithm, for that specific parameter set. That specific parameter set. So my question for Ramya is, then have you tried all the arrangement of the parameters? Or you just, because that is kind of a common mistake. Don't mean to put anyone on the spot here. It's just trying to tell you. So if you keep everything constant and change one thing, you're not reaching the best ever system. You're just comparing the variance of that variable, that knob that you're changing, with respect to everything else being constant. That's what you're doing. You're not coming up with the best configuration. To come up with the best configuration, you got to do grid search, or some sort of a search in your hyperparameter space or parameter space. Now, if you are doing that, if you're doing all of that entirely, like comprehensively, you're changing everything, and that's still your best performing algorithm, then that means for your data set, that is the optimal parameter set. And nothing wrong with that. Yeah, that's surprising to me. I don't think, to be honest, that's the case. But if it is, then that's your optimal parameter set. Okay. So let's move on to the project. So this part is hard. It's not hopefully as hard as your capstone. And it's hard because we haven't gone through extensively or in any way through PyTorch. We just installed it, right? That's why the notebook is well commented. So everywhere in the notebook, we're telling you exactly what we're doing. A lot of these processes, especially the low-level processes, you're already familiar with. We're just using a different tool to do the same thing. Some of it is very new because it relates to the theoretical parts that you learned. So you see a lot of connections between what you learned in my lecture today and the couple of last videos in your RNNs and your code. It's an RNN algorithm. So it's a good chance to get to familiarize yourself with PyTorch. I expect a lot of questions, obviously, so feel free. Use all of us, so we're all here to help you with PyTorch and get you started. But I thought that's the best way for you to, instead of going through general tutorials, actually solve a problem using PyTorch and learn. But we're here to explain. If I notice that this is too challenging, I haven't tried this yet. If I notice that it's too challenging, I come here and walk everyone through the code, and then have you do the project. But let's take a shot. Let's see if you can actually, with what you learned, you can actually look at the notebook and interpret it and ask questions and find it out at your own pace and you know, on your own. I find it very rewarding when people do that. Okay, so there is a link to the final project. Xiang, is there? What was the notebook called?
Assignment 1.
Assignment 1. Okay.
Has a URL like the material tab
Okay.
on the website. So okay. Go ahead and click on assignment 1.
You shared it on Slack.
It's on the website.
On the website.
It's shared on Slack too.
Okay.
Can you repeat what he said?
So yes. So basically, it's called Assignment 1, and it's in your members area in the course area on the website. It's called Assignment 1. That's your final project. Again, go to File. It's a Colab notebook, so you can't edit it. It's only I can edit it. Go and copy it to your Google Drive. Go to File, copy it to your Google Drive, and then start running over there. Some of the cells, some of the lines, some of the cells are question cells. That is, you don't have all the information there. You have to change a parameter to make it work, right? And that can be challenging and by design. So feel free to ask questions over there, and we're more than happy to help. But the notebook should be self-explanatory. So the point of the assignment is for you to replace those assignment lines, those question lines. It's very obvious. You go through them, but go through them linearly, right? Don't jump. um, and making sure that the entire code runs. Okay, that's first. But is it doing what you're supposed to do? Even when you replace it, if your code runs, also ask us to verify. Maybe you change something and it works, but it's not the best way. So still ask us if you're doing it right, and we're more than happy to help. You can also work in groups together, obviously, but it's good for each person to run the notebook. Everyone's got the notebook? Okay. Okay. So you sorry, earlier you asked a question. I ignored you unintentionally. Yeah.
So I'll ask Eson to come back to the Zoom call if you online people have any questions. So just give him a few minutes. He's answering someone's question right now. Okay.